Okay, this is a question from NTA mock test, and here in this question, you can read this question here. What is the radius of the imaginary concentric sphere that divides the electrostatic field of a metal sphere into two regions of identical energy? So here, first of all, the funda is that there is a metallic sphere, and the radius is given and charge is given. So if we assume that there is a metallic sphere here, so whatever charge is given to this metallic sphere, this q, which is 8 microcoulomb, that will be spread over the outer surface. And we know that inside the metallic sphere, the electric field is 0. Now this charge here, this charge q, whatever is there on the outer surface, it has got self energy. Now there is a funda that the self energy of this charge arrangement is stored in the form of energy in the electric field of it. Now where is the electric field of this charge q? The electric field of this charge q is outside this charge, and these electric field lines are radially out like this. So wherever there is an electric field, there is a electrostatic energy stored. So like electric field is extending up to infinity, and the electric field is of the form of kq by r square. And since the electric field is spread up to infinity, the energy is spread up to infinity. Now there is something called energy density in this electric field, and that energy density E in this electric field is equal to half epsilon naught E square. This is the energy density. Energy density means energy stored per unit volume. Energy stored per unit volume, and that is given by half epsilon naught E square, where E is the magnitude of electric field. Now we have to find out how much is the energy stored in the electric field of this charge. So let's draw this charge once again. Now what we are going to do is, this entire volume is there extending from this radius of A all the way up to infinity. That entire volume can be divided into small elements. Elements should be taken in such a way that within the element, the electric field energy density is same. Electric field energy density same means magnitude of electric field is same. So within a particular element, or this delta V volume that we take, within that elemental volume, there should be one single value of energy density, which means one single value of magnitude of electric field. And one single value of magnitude of electric field means one single distance from the charge. So you have to imagine a sphere actually, because in case of sphere only, you can say that all the points within the sphere are at same distance from the center of this metallic sphere, and because of same distance, the electric field kq by r square is same, because r is same. So what you do is, you imagine a sphere of radius r and thickness dr. So there is some thickness associated because we are considering the volume. So what is the volume of this element? 4 pi r square dr is the volume of element. Now what is the energy stored in this volume? That is equal to energy stored per unit volume, which is energy density, into this volume, 4 pi r square dr. Now what is the energy density at this location? At this location means location r. So at location r, we have to check what is the electric field. So electric field at location r is 1 by 4 pi epsilon naught q by r square. So square it, 4 pi r square dr. Now this will give you the energy stored in this elemental volume. Now you can take so many spheres, and in fact the entire this region can be divided into two parts. One part from A to some r, and the second one from this r to infinity. So two regions, A to r and r to infinity, and we have to divide this entire volume into two regions like that, A to r to infinity, such that energy contained in A to r is same as energy contained from r to infinity. And so what we need to do is, Now this is the energy stored in delta V volume or a small elemental volume. So how to calculate the total energy contained? Total energy contained means we have to sum up the energy stored in all these small spheres. The first part that we are considering from A to R. So for that we will consider this elemental volumes such that the first elemental volume we will take it at R equal to A, and the last elemental volume we will take it to from A to, like, let's say X, so A to X or A to R, like that. So energy contained from A to some X must be equal to the energy contained from X to infinity. Now half epsilon naught, this 4 pi, all these things will actually get cancelled out. So this, let me just cancel out the things. In fact, this q also cancels out, this 4 pi also cancels out. So the only thing which is remaining inside the integration is from a to x dr by r square should be equal to x to infinity dr by r square. So we get, so this is like 1 by a minus 1 by x is equal to 1 by x minus 1 by infinity. So x is equal to 2a. Yeah. Which means whatever is the energy contained from a to 2a is also the energy contained from 2a to infinity. From 0 to a, the energy contained is 0, because energy is contained wherever there is an electric field, and inside the metallic sphere the electric field is 0.